Hello everyone, my name is Rajesh Kumar and I'm your Devops SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNSEs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID. So please reach out to us, and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you.
Okay, so in the last session, we talk about the what is Kubernetes, why do we need it, how Kubernetes works, Kubernetes architecture. We discuss about the Kubernetes master server, their components. We discuss about Kubernetes worker server and their components, and then we discuss about the Kubernetes workstation and their components. So what we discussed is in the master server, we have a cluster store API server. Cluster store means powered by etcd, controller manager, and scheduler. That is making this master. The worker server, we have a kubelet, kubeproxy, and Docker. Okay, and then workstation, we have a kubectl, and then here this is a somewhere we this is our laptop and kubectl, and then we write a JSON file, and this is something which we write and send this JSON file to the API server, and all this thing happens. So this is something which we covered last day. So now let's focus on the JSON file because that is important. That is where you write a desire. So in Kubernetes, we have a desire, okay, and you have a desire and you can declare it in YAML file or JSON file, both. Okay, so now here you write YAML or JSON, and through kubectl from your workstation, you send this your desire to API server. Now, what can be a desire? So desire may contain multiple API resources, which I'll uncover this one by one. But let's say we know that pod. Okay, so here you said, hey, API server, which is a Kubernetes, part of the Kubernetes master, give me 3 pods of Nginx. API server stored that information in the etcd. Controller manager will report saying that, hey, there's no 3 pods. And when this was reported, API server will make a request to scheduler. Hey, scheduler, go ahead and schedule that 3 pods in your cluster, and now you got the 3 pods. You will see that here you had a 3 nodes, and each of these allocation by the scheduler 1 pod each node. So that is
Quick,
what it
quick
happens. So
question.
huh?
Yeah, I just have a quick question. So,
Yeah.
so when you're actually doing it locally and you want to deploy 3 nodes, how would you go about doing so? I think there's limitations when you use the Minikube. So how would you work around that?
There's no workaround as such. You can work with a one node cluster also, and you can work with a multiple node cluster also. So here in this scenario, I am having 3 worker node. For learning purpose, you may have 1 or 2 node. That's okay, no problem.
Okay, understood.
Yeah. So it can be thousands of node also, but right now not needed because of real learning. Adding a nodes, I'll teach you how to add a nodes. That's a very easy steps. Okay.
Okay.
Okay, so now this is what we have. So we desired 3 pods of Nginx, and we got the 3 pods of Nginx working in running in the node. So that is all. That is all. And now you know what has happened. Suddenly one node got disappeared because of some reason, maybe networking or CPU or RAM or disk space, or because of some reason one node is offline now. So remember that your desire was 3 pod of Nginx, but now because of that, because one node is not responding to master, now you have a 2 pods. So now the controller manager will get this information from the worker and said, "Hey, we got the only two. So hey, API server, we got the only two pods of Nginx. API server will query this one to the etcd and say, hey, it was a 3 pod. Desire was 3 pod. How come we got a 2 pod? That's not good. So let me instruct to scheduler one more time to replace one extra pod which was a desire. And now one extra pod got running in the worker node, and that is how the desire and the actual is been matched, and these are the all the component of the kubernetes is working in a sync to match your desire. Are you
Okay.
understanding?
Yeah.
So now
And then,
everything is done. Yeah. So now the question is, okay, so the most important question is, what else you can write? Let's say you just now I talked about the pod, but what else you can write in the JSON or YAML file? So this is your real learnings, okay? Kubernetes will be set it up. Now you need to learn API resources, API object, which is available and supported by API server. You need to learn, express it, and put it and send it to the API server. For example, let me put it up in this way. When you go to the AWS, you have a desire. What of a desire? You say, hey, AWS, give me VMs. Next, you desire, give me EBS, VPC, SQS, SNS, SCS. You desire for S3, you desire for RDS, you desire for Route 53, you desire for load balancer, correct? And AWS will give it to you, right? When you desire. In AWS, you desire using multiple way. How do you desire? You desire through console. There's a website using that you desire. You can write some code also, cloud formation code. You can write a Terraform code also. You can do the command line operations also. Correct, no? But in
yeah.
Kubernetes, we have a YAML or JSON file that is where you desire. In fact, command lines are there, and I'll teach you. So what to desire that? That means, see, Kubernetes setup. I'll set it up in front of you. Let's assume that it is set up and it is available. Master is set up, worker is set up, workstation is set up. So what else you want to learn? So how to express the desire? So in AWS, in Kubernetes API objects, these are the fundamental services you can say pod. Pod is like a compute unit. Okay, pod is like a compute unit where you can run your container. Controllers, replication controllers, like running a multiple pod. Services means load balancer, storage. Not these are the only objects you have. Okay, so many API resources you have. You have a deployment, replica set, stateful set, pods, new policies, config maps, secrets, config cron jobs, and so many. And your job is to learn all of these resources available at Kubernetes, express it in a YAML or JSON file, send it to kubectl, and rest of the things Kubernetes will do that. Okay. So now the first question is, what is pod? What is a pod? That's our fundamental services, foundation services. Like you go to AWS and you create a VM, virtual EC2 instance. Same way, when you go to the Kubernetes, you create a pod. But what is a pod? So understand in this way. Let's say when you go to the VMware, okay, when you go to the VMware, what you demand? VMware can do what? VMware manage what? So VMware manage VMs, virtual machines. Virtual machines come from the VM image, correct? So same way, when you go to the Docker, so Docker, what you demand? So you say Docker, hey, give me containers, and containers come from the Docker image again. Here VM image, Docker contain Docker container comes from the Docker image. Remember that in a VM image, you have a root file system, a boot file system additional. In a Docker image, you don't have a boot file system. No kernel is there in the image. So same way, when you come to the Kubernetes, you should ask pod, not, you should not say, hey, give me a container. Yes, this is odd, but you should ask pod. Okay, so pod
Right.
is a, when you come to the Kubernetes, you should ask pod, not a container. Okay, so pod is an atomic unit of scheduling in Kubernetes. Pod is a atomic unit of scheduling. Let me put it up in this way. So VMware can manage the VMs, same way Docker can manage the container, same way the work of Kubernetes is to manage the pod. Okay, so Kubernetes manages a pod. Okay, remember that VMs is running because of the PID1, container is running because of PID1, pod is running because of container, because pod contains container. So in a Kubernetes, pod is the atomic unit of scheduling. Okay, so look at this here. Containers always run inside a pod. Okay, and you can have multiple container inside a pod, which we have discussed. Okay, so now here if you look at this, let's say you have a pod and inside that you have a container. So all the kernel resources, network resources and all which got assigned to pod, okay, used by all containers of that particular pod. Okay, so all containers in a pod share all the environments which you assign to pod. Okay, so when you have a two containers, okay, in a same pod, that's called tight coupling. When you have one containers each pod, that is called loose coupling. Okay, so when you design a pod, you should not keep the multiple container, similar kind of multiple container, because it will not make sense, because pod is having IP address, not a container. So if you run 5 nginx inside a pod, you can be referring the only one container out of the pod, not all of it. So you should have a similar, if you want to run multiple similar container, you should have a multiple pod for it. Okay.
That's right. Okay.
So when you have a pod, the first container we call it a main container. Other container which you launch it, we call it a sidecar container. Sidecar container can be of any use, for example, log scrapper, database, or something like that, whatever your requirements are.
Okay.
Okay, so
How do you
sidecar
differentiate?
and
How do you differentiate between the cycle? What makes a cycle? Is
so
it something that you go on?
first container which you define, that will become a main container, and after the second onwards, that will become a sidecar container. So in YAML file, whichever way you define depends on that main container and sidecar.
Okay, understood.
Okay, so pods are atomic and which you can, you know, scale it, replicate it. So these are the pod life cycle. Remember that there is no start and stop. Mind it, pod cannot be started, cannot be stopped. Okay, container can be started and stopped, but pod cannot. So if you look at this, these are the life cycle of the pod. So pod, when you initially create it, it will be in a pending state, and then after that it will be running state, and then succeeded and failed. So that means if it is a pending, pod is pending. So if you look at it, the containers are not running inside a pod. That's the reason it's in pending. Now pod is running inside a container. Container is running inside a pod. So that's the reason it's running. And container, when it's complete the work, it can be succeeded and failed. So these are the life cycle of the pod. Okay, so when you have a two containers in the same pod, okay, how can you access it? So you can access the pod using the IP address of, you can access the container using IP address of the pod, but containers will have their same port, so you can access from outside. If you have a one container, then IP address and default port 80 it can be used.
Okay, and you're the one referencing the port, right? Or is that
Yeah,
something that is automatic?
no, no. You will specify which containers you want as part of the pod.
Okay.
Now, how they interact with it. So pod to pod communication, remember that in a cluster, so you may have hundreds of worker node. I repeat, in a clusters, you may have hundreds of worker node and a master node, and each pod talk to each other over the pod network. Okay, so pod talk to each other over the pod network. Okay,
Okay.
here if you see that there is a two container running. If they want to talk to each other, they can containers want to talk to each other, they can talk to each other through the local host, but from outside IP address of the pod and port number of containers.
Okay.
Okay, so what is a pod? So pod is having one or more containers. It can be your application or service, the most basic unit of work. Okay, in Kubernetes is a unit of scheduling. Pods are in feral, that means no pod you can get it redeploy. No pod you can redeploy. That means if you want the same pod, it is not possible. If you want the similar pod, it is possible. So pods are there or not. That means if the pod is terminated, you can get a replacement pod, but not the same pod. Okay. So what is the job of the Kubernetes? Job of the Kubernetes is to running the pod, and more specifically keeping the desired state which you specify the state, health, and so on. So that is the job of the Kubernetes. All of you understood that?
Yeah, understood. Understood.
Yeah. So now let's discuss about this. So here, after understanding the pod, what I am going to do, I am going to set up a Kubernetes cluster. So let me sum up this stuff. So if you look at this here, in a Kubernetes cluster, you have Kubernetes master server. We call it a control plane also. And then Kubernetes worker also we have. And then Kubernetes workstation we have. That's your laptop. Okay. So in the
Okay.
master, you have a multiple component, which I said API server. We have etcd cluster store. You have a controller manager. Okay, and then we have a scheduler. Okay, so these are the components which you have in the master. Now in the worker you have kube proxy. Okay, and then you have a kubelet. Okay, and then you have a docker. So these are the things. Now docker in 1.23 is being replaced by containerd, but docker still needed for downloading an image. Okay, so these are the components which we have. Now Kubernetes says, hey, run everything in Kubernetes cluster as a pod. So these all are application itself, right? So can't we run this all application in a pod? Yes, pod have a containers. Can we run it? Yes, possible. So you know what? Kubernetes is running all this application in form of pod, because if I can run my application in a pod, Kubernetes cluster components also can be run in a pod. Correct? So yes, this is the pod, and pod is having container, and container they come from the image, and image is coming from the Google registry. So all these images are coming from the Google registry. Are you understanding, all of you?
Yeah, I am. But I
Yeah.
did
So
remember reading something that said that the master does have access to kube proxy and kubelet,
yeah,
etc.
yeah, I'll talk about it. So here, so these all are component which is in form of cube pod. Now the question is, who can instantiate a pod? So if you remember the architecture discussion, in order to have a pod, you need to have a kubelet, because how can you get how can we get a pod without kubelet? So kubelet instantiate a pod, so that you need it. Then what else you need for the container? You need two things. One is a container D, and then Docker also. Okay, so these are the component you needed. Now pods will have a networking also, so kubeproxy is also needed here, and must be knowing actually kubeproxy is in also in form of pod. Okay, so now if you look at the architecture in the master server, these are the application which is running in a pod format, and pod to be there you need a kubelet, you and container to be there you need a container D and Docker. These are the tools need to be installed. Okay, so if I look at the worker chain, yes, this is in form of pod. So in that case you need all these component here also. Okay, so now this is the stuff. Now, remember that each of these components wants to talk to each other through the API server. So kubectl here also has to be there. Mind it. I'm placing the kubectl there also. And here also has to be there. And here anyways you have it, the kubectl, which is a workstation. So yes, these are the tools you need to install first, and then you can get it this one, and then this will get a kubernetes, this will get worker. Now there is a one man. So how do we get this all this let's say I install all these tools through commands. How do we get this pod? So there is one command which is there for us, and there is one utility has been given that's called kubeadm init. So kubeadm is a command line tool which need to be installed, which is for the administrating the Kubernetes cluster. And when you run command init, this pod will be created. I repeat, when I run the kubeadm init, all this pod will be created. And when I run kubeadm join, this command with some more extra parameters, this worker get attached to this master and create a cluster, be a part of the cluster. Are you understanding?
Yeah, I am understanding. And
Yeah.
kubeadm is only for Linux environments, correct?
Yes, yes. So theoretically, what we are doing here, just a second. So theoretically, what I'm doing here. So if you set up a master, first thing what you need to do is you need to set up you need to install these tools in each machines. So whether it's a master or worker, the common tool has to be installed. The only difference is in a master you run init, so this pod will be created initialization, and in a worker you just put the join with this master API server, and then that this worker is a part of the cluster. Okay, and then this utility you need to have in the workstation. This will talk to API server for rest of the operation. Okay, so this is the real architecture of Kubernetes. Okay,
Yeah.
so what I'm going to do, so I am going to do as part of this session, what I'm going to do, I am going to set up a two Linux server. Okay, and I'm going to set up two Linux server, and one I'm going to use for the master, and another one I'm going to use worker. Okay, and one of this I'm going to use the workstation. So let's use this. So first of all, let me go to the Azure. Here I'm Azure. You can go to it. You can create your VMs anywhere, AWS, Azure, Google Cloud, or your laptop with the virtual box and all. You can do that. And here I'm creating one machine, virtual machines, and I'll go for the Ubuntu 20. Okay. So the Ubuntu 20, why I'm going for it? Because for this I am having automated script available, okay, which will work for me flawlessly. Now if you want to set up a step by step also, so you can use that all the stuff and then get it running. So let's start it. So here I am creating one group which is called Kubernetes. Okay,
Okay.
Kubernetes new. Okay, click OK, and here I am going to create machines. So machine name master. Okay, and I'll go for any reason that's right now is not very much specifications is needed. So I'll go for 2 CPU 8 GB RAM, and here let me store these nodes, and here I'm going to use Azure user, which is for the master, and password I will have it. Let's create some password. Password here, and password. Now 22 port is open, but I want to open all other port also. So, and next. Disk I'll let it be. Networking, I'll let it be as such. Everything is okay. And review. And create. Okay, so this is the master machine. Let me create one worker also. Worker can be again Linux or Windows, but in this case Linux only. I'm going for it. So all resources. Here one more machines I'm going to create. Ubuntu again I'm taking, and which is a part of the same, and worker, and here password, your user, and password, and disk. Done. Okay, so I got the two machines here, and now I'm going to set up a master and worker. So let me go ahead and do that. So first I'm going to log into this is a machines. Let me refresh. So all resources. So what is the master IP address? So this is a master IP address. Okay.
And what image are you actually using?
Image is Ubuntu 20.
Oh, Ubuntu 20. Okay.
And where is a worker? So worker machines. Let me check.
Give me a moment. I'm gonna grab my charger. Okay. Just give me a second.
Yeah, sure. Yep. So worker machines. Refresh. Okay, so worker machine still, I think, is being created. Master. Uh, Let me see. Okay, I think let me create one more time. So Ubuntu 20
What was that?
worker 1 and password based, and here same password. Next, 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 next. Review and create. and create.
Okay, correct.
Yeah, got it. Okay, so now if you see that, I'll just go for refresh and worker has come. Okay. So worker IP address, you can see it from here. This is the worker IP address. Username and password, we have it. So that's good. Now what I will do, I will set up a master first and then worker. Okay.
Okay.
So how do we set it? So first I'll log into PuTTY server, and here I will just go, okay, open, accept, username is Azure user, and password is this one. So colors, just make it, click OK, apply, done. Okay, so this is my master server and sudo. Now all these tools I need to install. These are the tools, and in order to get this pod, you need to run this command. So all these steps has been automated in one of the script which I am going to show you. You can find it here. Just go to my blog and type Kubernetes cluster or something like that, and enter. And here all the tutorials you will have it. So this is an older version of CentOS 7 and RHEL. This is a Google Cloud, and here I think this one. So you'll be having the recording. This tutorial you refer it. So we are setting the latest version of Kubernetes with Ubuntu 24. So where is this code? All the code. So this code is all the shell scripting code. Just to save time, it has been automated. So now let me clone this repo. Okay, and now if you see that I've cloned it up, I'll go inside it, and now this script will run only in the master's Ubuntu 20.x, because uh, every versions you have a different steps you have to make it. So this script will install the master server, do all this thing which I talked about it, everything, and this script will do the setup of worker server, which includes everything. So can we run this chmod 755, and this I'm running in the master server, and done. That's all. So this script will take a few minutes and run and do it all for us. If you really want to learn step by step, you can open this script and learn this shell script one by one and understand the entire setup process. Are
Yeah,
you
I will.
understanding all of it? Yeah. So now what I'm going to do is I'm going to log into the worker server also and call that same way. So new, here, open up, accept. Now this worker server, I'll keep it blank. Okay. So mind it black. Okay. So here, this is the worker server. Username is same. I kept it. Password you have here. Okay. And done. Sudo -s. This is the root. Now I will clone the same repo in worker also. So hit clone and done. Okay, so now what I'm going to do, just wait for the masters to be there, and meanwhile I'll just wait for it, because until the master is set up, you'll not be able to run. You should not run the worker one. So you have to wait for it here. So I'll just relate test code, and here give the permission and wait for it. So chmod done. Now I'll have to wait for it because master server is not ready. So master server is not ready. So for that we'll have to wait for it. Worker cannot be created without a master.
Okay. Makes sense.
So now almost there. And in AWS or Azure, these steps will be faster. But if you try in the VMs and all, it will take a good amount of time. So that is something which you have to see that.
Okay.
And now I see that almost has been done. Last step is pending. Done. Okay, so now if you read this, see this command. I told you join command, right? And with some other parameter. So these are the parameter to set up a worker. So if you run this command in your multiple worker, then that worker will be a part of the cluster. Okay, this command. Now if you go up a little bit here, look at this here. Your Kubernetes cluster plane has been initialized successfully. If you want to set up a workstation, this one, if you want to install the networking, which is I installed it networking already as part of the script, Calico. And if you really want to add more worker to the master, this is the one. So this is the same command which I am showing you at the end of it here. So
Okay.
this command I needed to run in the each worker after running the setup command. So this after this script, I need to run this command at each worker. So that only this will be a part of. So this is the address of API server, some tokens and so on. So can I run this first worker? So it will install all the common tools which include this one. So this is the worker. Same tool sets you need in the master also and the worker also. That's the reason. But the only difference is in the worker you'll have a join command to be running, and in the master you'll be having init, which will get you all this code.
Okay, makes sense. But let's say, for example, like you have different nodes or you have it like different sectors or how I say this. Let's say you want to fit a lot of different nodes within one API call, for example, and you want to add more APIs to a particular downstream system. How do you go about specializing or like referencing where do you want to add that node to?
API address will be same for every worker actually. This will be the same. So this is the IP address of the API server. So you don't need multiple API server. I'm not talking about the HA right now because that's out of context. So first we need to learn the Kubernetes and then HA and stuff like that.
Okay.
So yeah, this is a common IP address for API server for entire cluster, and each worker has to run this command to become a part of that cluster. So this if you remember that kubelet is an agent here. This will talk to API server and create that connections. So that will be done.
Okay.
Okay, done. So worker, all this relation part is done. The only magical command which you need to run in the each worker, which is here, This script will display here. Let me run this. So clear the screen, copy, paste, and done. So now this worker is connecting to the API server and become a part of the cluster. Now see that it has been done. Now you can run this one in the your workstation and get it working. So now my master setup is done, worker setup is also done, and this is how quickly you can get it up and running for the learning purpose. Okay. So now last component which is pending, which is workstation. So how do we set up workstation? So workstation, your laptop, okay, I'm considering this your laptop. That's where you should be having kubectl, and kubectl, I need to know where is the API server. So here there is one file under the user home slash cube, okay, dot cube and config. So this file need to be there for kubectl, and in this file you will have an address of API server, okay, at user details and certificate details. So these are the three informations you will have in this config file. Okay, so
Yep.
we have this config file. So actually, if you might have noticed here, uh, there's some commands in this script which I run here. There's some commands need to be there in order to set up workstation, which I showed you earlier in output. So that has been run actually. So can we verify this file is exist or not? So let's ls $home dot cube, enter, and you see this file is there already. So can we see the content of it? So here more config. So now here this is the content, this is the cluster detail, this is the API server. Downside you have a users, and downside you have a certificate. This is a pretty large file, so you're not able to understand this way, but let me show you the commands. kubectl config view, and this is the short file. So what they have done, they have reedited and the certificate file. So now you see that how many clusters you have, only one in this config file. You can manage multiple clusters. So right now only one named with Kubernetes. And how many users you have, only one named with Kubernetes ID admin. And context is to combine this cluster and users. So this is the context. So that means your context name is this one, and this is the cluster which is coming from here. This is the user which is coming from down, and this context you will log in, which is set in the current default context. That means by default you're set with this API server and this user. Okay, so now this is done. So let me tell you here, for this demo and all, I'm setting up the workstation in the master server only. You can set it up anywhere, wherever you have a kubectl and this file, that workstation can be anywhere. It can be in your laptop.
You chose to only set it up in the master.
Yeah, so I have set it up in the master itself, and this file is there. And now can we validate whether, so now you consider this machine as a workstation, not as a master. Okay, though I have set up workstation in the master only, because of this configuration, wherever you do, the workstation can be set up. Okay, so can I check this kubectl get nodes, and I'm checking that my server is ready or not. Now if you look at this here, this server master is ready and worker is ready. The version is 1.26 and good to go. So now can I show you these pods?
Wait, quick
So
question.
here, yeah.
What's the difference between a node and a pod?
Node is nothing but the virtual machines. Okay,
Running on the
node
pod.
uh, node is a virtual machine. So master is set up in the node, worker is set up in the node. So master node, worker node, these are has to be machine. It can be physical server also, virtual server we are using nowadays, but it can be physical server also, where you run our operating system. Nowadays we all things we run in a virtual server, right?
Yeah.
Okay.
Okay. Understood.
So, so that is the stuff. So now here you have a two node, which is master node, worker node, and workstation. I have made it this one. Good to go. Can I verify all these pods? So you'll see that all this pod qctl get pods hyphen hyphen all, not uh,
Okay.
just a second. All namespaces. What is the namespaces I'll talk about here? So look at this here. These are the pods. So where's the pod of API server? So here it is. Where is the pod of etcd? Here it is. Controller manager, scheduler. Remember there is a two worker, so two proxies there. Okay, two node we have, two proxies there. This is the discovery services related. This is the networking pod. Okay, so yeah, this is the one. See here. Are you understanding so far?
Yeah.
Okay,
Well,
so now my cluster is up and running with all validation in check. Okay, so now what do you want? That is the question. What do you want? Kubernetes is asking, hey, you set up the cluster. What do you want? So that is the next question. That is a next question. What do you want? So what do you want? So I need namespace. I need a pod. I need a replication controller. I need a deployment. I need service. Okay. I need PVs. I need a PVCs. I need IAM. So these are the services which I'm going to talk about. These are the, you can say IAM, not sorry, RBAC. IAM we call it in AWS. So these are the services which I'm going to talk about it. Okay, which will help you to get it up and running.
okay.
Okay, so what is the namespace then? So let's put it up in this way. One in diagram I needed to show you what is the namespace. So this is your cluster, okay? And Kubernetes powered by how many worker? Let's say one worker, two worker, and three worker. I must remind you, Kubernetes still view that all the worker in as a one compute unit because of that's the concept of cluster, right? So now there is a one, think about it. There is a problem statement I'm talking about. So these clusters, you have a three machines. So here 5 GB RAM, 5 GB RAM, or whatever it is. Altogether, we have a 15 GB. Okay. So 15 GB capacity of the clusters which you have. So now for organizations, here you have project A, okay, and project B. So project A deploy their pod here. So one pod, two pod, three pod. Project B also deploy their pod, one pod, two pod, three pod. Now the problem is like that you will have in our organization, you will have a single clusters and multiple projects will be using, multiple teams will be using. Now the problems which we'll have is, let's say this pod you have a bug, and this bug is consuming lots of CPU and RAM, and because of that B also has to experience the downtime, because remember that this pod is running in this node, this pod is running in this node, this pod is running in this node. So that way theoretically all the nodes will be impacted. So this project is also being impacted because of the bug in this. So how do we solve it? So that is where Kubernetes is coming up and saying that, hey, let's do one thing. Let's keep this, divide this whole cluster, not physical division, logical division. See, physical division when you do, so divide one worker like that. No, I'm not talking with the physical division. I am talking with the logical division. This way. Okay, so now I will create one logical division in Kubernetes, and that we call it a namespace. This is a namespace. This is also namespace. Okay, so that way what you can do, I can set the namespace saying that, hey, this is a project 1A namespace, and maximum you can use 6 GB, and this also namespace you can use maximum, let's say 10 GB. Okay, sorry, 5 GB. Okay, so now no matter how many pod you are running in each of this worker of the cluster, but all this pod combined, you can maximum ask from Kubernetes 6 GB. So you cannot impact the other projects. So now namespace is to divide, I repeat, namespace is to divide the Kubernetes clusters resources. So you can, for the each project, each team, so each team will not get impacted from each other and so on. Make sense?
Yeah,
When
makes
you
sense.
say resources division like a RAM, CPU and all, you can divide, storage and all, you can divide. So now next thing is also namespace can be used also for granting access. So let's say there is a one engineer here and by mistake they deleted this pod. That is not a good thing, right? So what to do? So now there is engineers, you can assign the access only not to entire cluster but to namespace. This engineers also assign access not to entire cluster but to namespace. So namespace has become a way to divide the clusters between the multiple project and multiple teams for what? For resource sharing and access. Resource means CPU, RAM and storage. Access means read-write access to only particular namespace, not out of it. Make sense, all of you?
That makes sense.
Okay, so now we have understood what is a namespace. Now, the question which is a very common in the all the resources is like how do we create, how do we read, how do we create a namespace pod RC deployment services, how do we read namespace RC deployment services, how do we edit, how do we modify. So we have a, remember that CRUD. What is the CRUD? Remember that API server.
Update, delete.
So API server, I said, if you remember that, API server, you have multiple API. API 1, API 2, API 2, API 3, and so many APIs you have. This API, we call it, one API we have a namespace, another API we have a pod, other APIs we have service or whatever it is. So these are the APIs actually. So how do we call it? So we call it using, you call it using CRUD pattern. Okay, CRUD means create, okay, read, update and delete. By the way, I would like to know how many API resources we have. So let me ask this question. So I'll write a kubectl, enter, and lots of commands you have. So these are the commands you need to learn. Okay, I'll teach you. So now one of the commands which we have API resources. So run and see that here. This API resources, plenty of it. Okay, let me make it in a large one. See, a lot of resources here. Some of the resources which I was talking about is pod. So pod is somewhere here. Node. Okay. This namespace just now I talked about it, right? So
Yeah.
here. Yeah. So this is the all the resources. If you want to know their API version, different API version. So this is the API version for each. So pod is all this pod and all. It's a V1 actually here. This is the version. Okay. So these are the resources you need to learn one by one. Okay, so CRUD formula. So how do we do the CRUD? How do we create a namespace? How do we read the namespace? How do we update the namespace? How do you delete? There are two ways. One is command line. One is YAML file. This is also you can do through command line YAML file. Command line YAML file. Delete command line YAML file. Now let's try with the command line. So let me run this kubectl. Enter. So now if you go up a little bit, study properly, these all commands are there. So which command will help me to create? So here there's a command called create. Which command will help me to create through YAML? So create -f YAML file. This is a pattern I'm teaching you. This will work for every. Okay.
Okay.
Read which command? So there's a get. Okay. So get and there's one more command describe. Okay. Now for YAML, same command -f YAML -f YAML. Now, how do you update it? So there's one command which is called edit, 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 and there's a how do you update through YAML? So apply hyphen f YAML. How do we delete it? So there's one command which is called delete. So see that it's very simple pattern for every resource, not only for one, every resources, and hyphen f YAML. It's simple. So now, how do you work with this all the resources which I showed you? You have and with you. Okay. So now, what to do? So guys, I am going to create pod. So what is sorry, namespace first. So where's the namespace? So here I'm going to create a namespace. So using command line, command line, command line, command line. Can we do that? So let's do that. So how many namespace we have already? So kubectl get ns. Ns is a shortcut for the namespace. So you know what? Any pod which you create, this will be created in a default namespace. Why? Because that is default. Okay. So every resources has to be created in a namespace now. You cannot create in a cluster. So now there's a multiple namespace you see. This namespace is used by Kubernetes to run those pods of cluster, and public namespace for you can use node for admin default. So I want to create my own namespace. So how do I create it? So create ns dev one more namespace qat. See that? So easy. Get ns. Now you want to describe there some of the namespace. So see here, describe ns and dev. This is the description. Okay. So get, create for creating namespace, get and describe for reading it, updating it, edit. So can we do that? So edit, I'm editing the namespace which is created by me, edit, and here what you want to do. So right now still you are progressing in this world, so play with the labels which will not impact anything. Space, and what is the team? This is for Devops school team, something like that. Okay, so I added one labels, save it, describe this and see that if the label is there or not. See it here, and then finally your work is done, delete it. So simple. And you see that I did the CRUD, create, get, describe, edit, delete. Command line, I work with one. So same way you can work with the rest of the resources also using command line. Are you understanding, all of you?
Yeah, I understand.
Okay. So now next resources, just a second. So next resources which I am going to show you, just a second, spelling mistake. Next resources which I'm going to create, and that is pod. So pod is the most important one, right? Pod is most important. It's like a pod is like a VMs for Azure, VMs for EC2 for AWS.
Okay.
So that's the pod. So now this time I'll not create a pod using command line but YAML file. So where is YAML file? So let me search for it. Pod example. And here some examples, you can get it from the internet also. Right now I'm using mine because I want to control the image of it. So here this is the example. Hey, what do you want? You want pod. Okay, what is the version of that? V1. Still that V1 is there, V2 has not come. So what do you want to name this pod? So I want to name this pod Rajesh. Okay, and you want to label something? Yes, label tagging or something. Yes. Pod will contain containers, multiple containers. One of the containers you have here, and this containers, the image is here, and port 80. So you can want to learn multiple containers. Here it is. Okay, so you cannot run two containers on the same port in the same pod. So you have to keep it different. So two containers right now, but I'll just delete it. This one, let it be one. Simple. Are you comfortable with it?
Yeah, I'm comfortable. I understand.
Yeah. So now what to do? Just copy, Okay, look at the screen, all of you. And here bi pod.yaml and paste it, insert, done. And kubectl get ns. So I have a QANS and default ns, which is a default. So what to do? Same way I taught you, create first get pods default. This is the default namespace. I want to get the pods in a QA namespace, like n, you have to specify hyphen n and QA. So there's no pod. So can I create a pod in the default namespace first? So kubectl create hyphen f. What is that? Pod.yaml. So this is created in a default namespace. Now in the QA namespace, there is no pod. Can I create it? Hyphen n is equal to QA. I created in the QA also. See that. So now pod is created. Get, see here, pod is created. You want to know the pod information? O wide. See, this is a pod IP address running in the worker 1. I have only one worker, by the way, and good to go. So now I create. How do I read it? How do I read it? So kubectl get hyphen f pod.yaml, kubectl describe. You can use a command also, the one which I taught you, same pattern. This is the command, and you should go for this, all this option. This is the IP address, here status, all the containers and all this
So will it
information.
display the same context within the logs?
Yes. So I'll show you that logs. How do you see that? So this, you are describing the pod. Okay. So you can do through the command line also. Now you want to edit the pod. So how do we do that? So vi, I can do the edit through the command line, but I'm showing you through the YAML operation. So here pod, let's say with labels, team XYZ. Save it and apply kubectl apply hyphen f pod.yaml, enter. And now describe the pod, and you see that somewhere labels.
Okay, quick question. Do you write out your
Yeah.
whole YAML files, or do you actually use the dry run to
Do
get the YAML?
you? Oh, this
My,
YAML, there is automated way to get it also, but right now just read it through this way. This is the best way.
okay.
Yeah. Okay, so this one. Now, last thing which I need to do is delete. So can I delete this pod through YAML commands? So kubectl get pods is the pod and delete using YAML delete hyphen f pod.yaml. This is deleted from the default, and this is deleted from QA namespace. So
Okay.
now the pod is gone. See, pod is gone and QA gone. So this is the way. Remember that you need to CRUD every resources which you saw, around 57 resources you have. So you have to do that. Are you understanding?
Yeah, I'm following.
Yeah. So now you wanted namespace, I got it. CRUD, I did it. You wanted pod, I did the CRUD. But pod, you have to spend a little bit more time. So what time I'm talking about? So let's do understand this. How can you access the pod? kubectl enter. So these commands we need to understand. This is called troubleshooting and debugging commands. Okay. Before that, let me grab all the commands which I run. So history. So you'll be having in recordings. So you can check it out. So this is the command. Okay. So now what to do? So describe, you know that. So I'll just keep it out of this. Logs attach exec go forward proxy not needed now. Auth debugging not needed. So these are the commands. So the question is very simple question. Pod is created. How do we access it? So let me show you here. Let me create a pod one more time. So I need it. So this time I'm working the default. Okay. So apply directly. You can do that. Pod.yaml. File name can be anything, by the way. So kubectl get pods, which is the pod Rajesh pod. Now, how can I access it? So you can access from outside IP address within a cluster. Okay. So here this is the container pod called HTTP. This is my image. So this is coming. You can access inside a cluster. You can access it. Welcome to Devops School version 1. Now, if you want to go inside a pod, you can do through the exec commands. How do you? kubectl exec it interactive mode, which pod? Rajesh pod, and what you want to exec with? Bin bash. Where are you? So you are inside a container, not inside a pod. I repeat, you are inside a container, not inside a pod, because pod is a logical unit. Pod is not a physical unit. Container is a physical. So right now you are inside a container and you can do whatever you want inside of that container. You can access from outside, you can go inside it, exit, and so on. So now this is something which I taught. Now there is a one command which is called logs. How do we see the logs of the container in the pod? Mind it, logs pod do not generate any log. Pod is a logical unit, do not generate pod. So how do you do that? So how do you see that? So kubectl logs Rajesh. See, I have only one log. So if I hit one more time, and if you see the logs one more time, see 2 lines that way. Attach. So if you want to attach the PID1 of the container of the pod, then you can do the attach. So kubectl attach Rajesh. So there's only one container where you are. So basically you attach to the PID1 of the container. So now if you hit this one, let me try to hit from the other nodes. Enter. See here logs you are able to see. HTTPD, you are on HTTPD now. That way. Okay, so that's you can attach to that. So if you know Docker container, it's the same behavior we have. Now understand this. The pod is accessible. This pod or this pod is this pod or this pod is accessible anywhere in any worker because of kubeproxy. Okay, it's accessible inside it, and that's one of the reason I set up workstation somewhere in the master node. Okay, so I can connect. So master and node anywhere this pod can become connected, but from outside if you want to connect, you'll not be able to connect because the IP address of this scope is local. So what to do? So that is where then you have to do the port forwarding. It's like a -p in a Docker, okay, container. Okay, so how do you do this? So I don't remember the commands. So let's say if you don't remember the commands, you also, then no need to go to the Google. Just try this pattern: kubectl -h. What you want? I want port forward. Where is that? Here. Yeah. So here you just type kubectl port forward -h. -h, you remember that. Now there's so many options are given. Example. Okay. So one of the example I need for the pod, not deployment, not service, only pod. So I think this will work for me. Okay. So what do you want? I'm creating a port forwarding from should be accessible from all the IP address. Which pod? Rajesh pod in a default namespace. What is the pod IP address? So 80, I know. This 5000. No, sorry, this is a 5555. This is the node port number. That means this pod will be exposed at the node port number. So node IP address can be accessible. So and this 80. So this is the node port and this is the container port. Done. Default namespace. Enter. And see now it's forwarding. Now if I remember the IP address, any one IP address you can use for this. So IP address is master or worker, any you can use. and the port number is 5555, right? 555. Okay, so it's not accessible. Why? So if I try internally accessing it, curl http. If I try internally, also it's not accessible. So the reason is this one, security groups. So let me go to the worker machine, or where is security group? Networking. Uh, Here. Okay, and here you have to out inbound, you have to add this, and what I'm doing 5555, I'll do any service all dangerous one, by the way. All is not there, no problem. And here star, this is not good, but I'm adding it. Worker machines, same thing you have to modify in the master also. So let's try worker now because I did changes. 555 and should be accessible. Let me still it's not accessible. Uh, okay, I should check the firewall also. So okay, let me do with master also. Uh, Inbound 555555 any none. So let's use the IP address of master and 5555. Still I'm not able to access. So here let's refresh it. Master server, uh, name, port, protocol, source, destination, allow. Should be accessible. Is there. Okay, so done. So you can access it from the that one. Okay, so now, so here, if you see that, you should do the port forward. Now you want to copy some files inside a container, you can use the cp command. Are you able to see that? Hello? Hello? So here, kubectl cp get pod, and I will copy inside a temp file. So exec Rajesh pod ls tmp. And no files is there in the tmp. I'm going to copy this file. So kubectl cp this file to Rajesh pod, container only one, so tmp. And now see what YAML. And last command which you see, you can check the authorizations of this. What author? I have admin privileges, but still if you want to check it, auth. So here can I, and this format you have to specify. Can I create pod? Yes. Can I create namespace? And so on. Have admin privileges every time you'll get yes. So guys, this is the way we have you wanted to desire a pod and namespace using CRUD, you can do that. Understood, all of you?
Yeah,
Does it?
understood.
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.